This is actually a special problem in development of surfaces, that is case 3, development of a path. When an insect is moving around a solid object, otherwise a point on the solid object is moving around the lateral surface of that particular object, you have to trace the path of that object. Normally in university question papers, they will give you one example like this: an ant is moving around a cone, or an insect is moving around a cylinder, or something like that. You have to mark the path traced by that ant or insect. That is the third type problem from development of surfaces. So here we have one question: a particle which is initially on the base circle of the cone, standing on HP, moves upward and reaches the apex of the cone in one complete turn around the cone. Draw its path on projections of cone as well as on its developments. Take the base circle diameter is 50 mm and the axis height 70 mm. If you don't know how to draw this, but you know how to draw the front view and the top view of a cone. Front view is a triangle and top view is a circle. Just draw the top view and the front view of the cone like this, and divide the circle into 12 or 8 equal parts. Here we are dividing the circle into 8 equal parts. So you can draw the front view and the top view like this. The generator lines are represented using very thin lines. So you have to mark the front view and top view like this. The ant is moving around the cone. We are assuming that it is taking same angular distance in each time period. So you can divide the movement of the ant in different time intervals, and all the time intervals it is covering the same angular distance. That is an assumption. And we are also assuming that during that travel it is covering the same height. See, the ant has to move radially and also axially upward. The ant is moving around the cone, so radial movement is there, and it is moving upward to reach the axis. The ant is starting from the left extreme corner point, one point on the base circle. So I am taking the left extreme corner point here, A dash, and at the end of its journey it has to reach at this point, O dash. So you have to divide the height into equal parts. Here we are dividing the circle into total 8 equal parts. So you can divide the height into 8 equal parts. And before that you can draw the development of the cone is a sector. You have to copy this slant height as the radius of the sector, and you know how to mark the end of that development. Theta is equal to 360 into r by l. R is the radius of the cone, l is the slant height. Then you will get a theta value. So this is the development, and you can mark points on the development. This is capital A, B, C, D, E, F, G, H, again A, because if you are folding you will get the same A in 3D. So we are marking capital letters in development. So as I told you, I am dividing the height into 8 equal parts because you will get 8 steps. It is our assumption. We are assuming that during equal intervals the ant is covering h by 8 height, and it is taking 45 degree radially. So h by 8 height axially and 45 degree radially in equal intervals. So now let's take the first point on point A dash, because the particle or the ant is starting from point A dash. After 45 degree rotation, it will reach at a height of h by 8 from the bottom surface. So from xy line it will reach a one step height. You are dividing the total axis height into 8 steps. So it is moving radially 45 degree and axially actually h by 8 height. So the second point is here on B dash O dash line, on this line, at a height of h by 8. Third point should be on CO line or C dash O dash line in front of you. The height should be here. Fourth point is on F dash D dash line. It should be here. Similarly, you can mark all the remaining points. So if you are drawing a line connecting these points, you will get the path in front of you. So this is the path in front of you. See, these points, point on AO line, BO line, CO line, DO line, EO line, they are visible in front of you. Observer is standing here. If he is watching the object from here, all the other points, point on FO line, GO line, HO line, they are not visible. So the points connecting, the line passing through these points up to here, they are visible. So you can draw continuous lines. The line passing through these points behind the AE diameter, they are not visible. So we are drawing dotted lines. So our the path will be like this. Up to this we have a continuous line, then we have to draw dotted lines. So this is the path in front view. Now you can draw the path in top view. Just project the points downward, mark them, then project the points downward. See, it is very difficult to mark points at the center, point 2 dash and point 6 dash. To mark point 2 dash, you have to find the radius at this height level, then rotate it, so you will get a point 2 here. Similarly, to mark point 6, you have to mark the radius at this height level, then project it, then you have to rotate, then only you will get. And we can mark all other points by just drawing the projection lines. Draw the projection lines like this, then mark the points. First point is point 1, all other points are this is point A, second point is point 1, 2, 3, 4, 5, 6, 7, and finally point O dash. So all the points are visible in top view because all the points are visible in the top surface because it is a cone. So you can draw a continuous curve like this. This is the path in top view. Now we have to mark those paths in this development. See, in this development, AO line, BO line, CO line, DO line, EO line, and all these lines are actually representing the generator lines. All the lines having same length, true length, AO equal to HO, that is equal to GO, because they are the radius of the sector. But in the front view, all the lines having different length because only A dash, O dash, E dash, O dash, they are parallel to a VP. That's why they are getting the extreme generator lines. They will give you the true length of the generator line. All other lines are apparent length. To get the actual length of each point corresponding to the true length of the generator line, you have to do one thing. You have to project this line to the end generator. Point 2 to the end generator, 3 to the end generator, 4 to this end generator, 5 to this end generator, 6 to this end generator, and 7 to this point. So these height levels will give you the exact position of points in generator lines. Let's look. You have to copy the points like this. To mark the distance of point A, see, point A is already on XY line, there is no distance. You can mark point A here, 0 distance. Point 1 is in BO line, but this is B dash O dash line. It won't give you the true length in front you. Here BO line is equal to AO line, but in front view, BO and A dash O dash, they are different. So to get the exact position of point 1, what you have to do is you have to draw, the step is already there, you have to draw that parallel line here to A dash O dash line. So you will get this point, the arrow. So measure the distance between A and this much distance, then you will get a point 1. Using divider, you can copy this distance between this point and the A dash. Similarly, from 2 also you have to draw the parallel line up to the end generator. So point 2 is here. Take the distance between this mouse point and the A dash. This is the actual height of point 2 in generator final development. Mark that point. Similarly, take the distance between the parallel line, this point, intersection of point, this parallel line and A dash. Take the distance between this point and A dash. That will give you distance of 0.3 from this base D. Similarly, you can draw parallel lines to the end generator lines. You have to take the distance from, see, we are measuring the distance from the base to the apex. So you have to copy the distance from this curve towards the center apex. Some students will make some mistakes. They will take the distance from point O. If you are doing like that, you will get a wrong answer. So better take the distance from the XY line, which means take the distance from the curve. So you can mark all the points, join them, all the points are visible. So this is the development of the path. So this is how we are drawing the section path in front view, top view and the development. Thank you.